Okay, welcome everybody to today's webinar, which is going to be on the topic of natural hazards triggering technical disasters and NaTech and climate change are ever-growing challenges, particularly the high hazard industries, but there are plenty of safety implications of those events, and we need to look at how we assess the associated risks. This is the third of a series of webinars on the general topic of climate change adaptation, and we will have Aimee Russell leading it. I'm Richard Talleyrand. I'm just a volunteer for IMechE and hosting the event. I'll hand over very shortly to the chair, Tim Fox, so he can carry on. The event will be recorded. It is being recorded now, and we will upload it to YouTube after the event. We are disabling your cameras and your mics for a smoother presentation, but you'll get those who attend most of it of the webinar will get a CPD certificate. You can put in questions at any point in the Q&A or the chat tabs, and we'll track those and make sure we get to them at the end of this webinar. The slides will be available as a PDF afterwards, and when we send out CPD certificates, we'll also send out the slides. Just if you're trying to use an AI chatbot to summarize this, if I see them, I will kick them out of the meeting because you should be paying attention. Now, just a little bit about IMechE and our process industries division. We a central point for mechanical engineers, mainly in the UK, but also somewhat globally as well, to connect, share experience and promote best practices within the industries. We've got a lot of industry sectors, and if you haven't come across this before, we do go about organising specialist lectures, seminars, conferences. We talk to government, particularly in the UK, about the process industries, and we try and promote education, training and CPD. We are a very diverse organisation. We've got 108,000 members last time I looked, and from all backgrounds. So we believe engineering's for everyone. We want to foster an inclusive culture for no matter what your backgrounds, your sexual orientation, doesn't matter. Everyone is welcome. We're all interested in engineering. If you want to get involved, just contact us and we will do that. And at that point, he says, I'll now hand over to Mike Fox, to Tim Fox, not Mike Fox, apologies. Who's going to chair the event for us. Tim.
Thank you, Richard. And also welcome from me to this webinar to you all. As Richard said, this is the third episode in our series that we've organised through a collaboration with IChemE and IMechE that's looking at the issues of adaptation in relation to the high hazard industries in particular, but the broader process industries more widely. As Richard said, my name is Tim Fox. I'm a past chair of the IMechE's Process Industries division, so the division that is hosting this, and I'm chair of the IMechE's Climate Change Adaptation Working Group. And I'm absolutely delighted to be chair for our event today. We've got a great set of contributors. In this webinar, we have Aimee Russell, a senior process safety and technical analyst at RAS. And she will combine her background in natural hazards with her 10 years of experience in process safety to provide practice-based insights into the world of NaTech, or NaTech, however you want to pronounce it, and climate change risk assessments. Aimee is going to describe, as well as an overall background to the topic, make a very specific overview of the a method which can be used to perform such assessments, as well as present some real world examples of NaTech events and what we can learn from them. I'm really excited about this webinar where we're going to delve into some real world challenges and real world issues. After Aimee, we'll be joined by Mike Nicholas, who's an industrial adaptation expert at the Environment Agency. he's going to join us for the Q&A and panel discussion. Mike provided the first talk in the series for those of you that have been on this journey with us. You'll recall he gave an excellent overview of the topic in its broader sense, and gave us some perspectives from the Environment Agency. So we're going to be addressing your questions in the Q&A after Aimee's presentation. So do please post the questions in the Q&A function if you can. But we will be looking in the chat as well to see if you have posted questions there, and I'll be chairing that session. Full biographies for Aimee and Mike can be found by clicking on their photos on the web page where you registered for this event. So without taking 10 minutes to go through those very interesting bios, I'm going to hand over to Aimee and get the meet underway straight away. Over to you, Aimee.
Thank you, Tim. Okay, can we all see that? Perfect. So, hi everyone, welcome to this webinar on Beyond the Storm, the risks of NaTech disasters. So before we get going, I'll just give you a little bit of background to me and what we're going to discuss. So as Tim stated, I have a background in natural hazards, and then I've spent the past 10 years in process and technical safety at RAS Ltd, which is a consultancy based in the northwest of England. In this webinar, I'm going to take you on a journey of NaTech and climate change with the viewpoint of setting up a framework which can be used to help you assess these risks. This is just one approach which could be used. There may be other frameworks and ways of doing this out there. It's important to remember that when we're looking at these events that they are complex, but it doesn't mean we shouldn't try and understand how we may be impacted. Using this knowledge allows us to build resilience where we can, understand where we can't, and help us make better informed decisions. This is even more important with climate change, as these events may become more likely and become more devastating. So to begin with, I will just provide a context of what do we mean by natural hazard, climate change, and NaTechs for those of you that haven't been in the previous webinars, and then I will talk you through the framework that we use to assessing these NaTech risks. So what is a natural hazard? Essentially, a natural hazard is just an extreme event which poses a risk to society and or the wider environment. So on your screen, you will see some examples of these events. They can occur over various scales, from local events such as a tornado all the way up to an international event such as a tsunami. We also have something called secondary natural hazards, which are events which are triggered by an initial event. So a good example of this would be an earthquake triggering a tsunami. These events will also occur over various time periods in both how frequently they occur and the duration of event. So some events may only last minutes, while others may last days. Some events may occur yearly, while other events may only occur every 100 years or even every 1,000 years. So when we're talking about climate change, we're looking at those long-term changes in the Earth's average temperature and weather patterns. They can have a lot of effect. The main one that we're interested in is those changes in that extreme weather event. A key aspect of climate change is also the rate of change and our ability to adapt to the changes that are occurring. Now, there are a lot of buzzwords around sort of climate change, but the two key ones in this context is mitigation and adaptation. Now, in process safety and in high hazard industry, we're very used to mitigation. We use this as a barrier to mitigate against major accidents. But in the context of climate change, mitigation is more around the prevention of the emissions of greenhouse gases, with the goal to limit the future impact of climate change. Adaptation, on the other hand, is how we adjust to the changes that are already happening to minimize the damage which is caused. So essentially, mitigation is reducing the emissions, adaptation is making changes. So when we're looking at this from a NaTech perspective, we want to be looking at climate change adaptation. So how do we know what the future holds? As short, we don't know for definite, but there are a number of climate change models and scenarios which we can use to help us determine what is likely to happen. So there are a number of models. In the UK, we will use RCPs, scenarios which are determined by the IPCC. Now for this, there are 4 main pathways that we would use. RCP 4.5 and 8.5, which represent a 2 and a 4 degree warming by the end of the century. Now, where we have sites that are highly vulnerable or are going to operate beyond 2100, such as nuclear sites, we may sort of add in additional conservative scenarios. So now we've looked at what a natural hazard is, and we've looked at what climate change is. What exactly is a NaTech? So a NaTech is where we have this natural hazard event that causes operational and safety challenges at an establishment, resulting in a technological event. So an example of this would be a flooding event causing flotation of a storage tank at an oil storage site, resulting in a loss of containment. That would be a NaTech event because we've had a technological event that was caused by the flooding event, which is a natural hazard. It's really important to remember that these events already happen. So this is just some events that have happened over the last 35 years or so. They happen all around the globe, and a lot of these do also happen in the UK. So if you're a coma site or a high hazard site in the UK, we really do want to be thinking about these. So now we've set the context of what these events are. How do we actually assess them? So essentially, I use 5 broad stages. So the first stage is we want to look at screening. What could impact us? We then want to look at severity. How bad could this be? What would it look like? We then want to add in our barriers. So what do we have to prevent this from happening? Or what more could we be doing? Then how are we responding if this does happen? We want to think about our emergency response. And then finally, we have our management system, which should confirm all of this is in place. So if we start with screening, essentially the purpose of screening is just to identify what are your credible natural hazards, both now and under climate change. We want to determine our secondary or associated events that could occur alongside those natural hazards, and we want to rule out our non-credible events. So if you're in an inland area, you can probably screen out coastal flooding from occurring. Just be really careful when you're ruling things out that it's not just because it's not occurred in a few decades. We've got to remember some of these events are on a geological timescale, so that's much wider than what we would see with hurricanes and windstorms. So how do we screen? So first of all, we want to look at what natural hazards could impact the area of the world that we are looking at. Then we want to look at what is my risk to my site? What is my baseline? We then need to understand how climate change could impact this. And more importantly, how does this change from our baseline? And then finally, we want to make sure we're circling back to those secondary events. So your list of natural hazards, like I say, is going to massive globally, vary globally. In the UK, we're going to want to be thinking about flooding, temperature extremes, wildfires, thunderstorms, windstorms, landslides, earthquakes, subsidence, coastal erosion, and that's just the start of the 10. The CDOIF adapting to climate change guidelines will also highlight other natural hazards which we would want to consider in the UK. Now, natural hazards are complex and they have a multitude of interactions and in some cases feedback loops, which makes assessments become very complex very quickly, as I will explain in the next 2 slides. So if we start with our geological hazards, we have earthquakes, volcanoes, and landslides. Now, if we're looking at volcanic eruption, depending on the volcano type, we could be looking at lava flow, lahars, pyroclastic flows, and ash clouds. For earthquakes, we'll definitely want to look at ground shaking, and again, depending on your soil and sediment type, you may want to be looking at liquefaction. There's also the potential for flooding if dams get damaged. So we've got our 3 primary events. But we have interactions between these events. So earthquakes and volcanoes often coincide. Earthquakes can trigger landslides. A landslide can trigger a volcanic eruption, as happened in Mount St. Helens in 1980, and volcanic eruptions could technically trigger a landslide. All 3 events have the potential to trigger a tsunami, although other factors also need to be considered for that risk. So all of a sudden, you're potentially a site that could have a volcanic eruption, a tsunami, a landslide, and an earthquake all happening at the same time. How do you risk assess that? That's a very complicated risk assessment. So we simplify. So what we do is we look at what would the worst case earthquake look like? What would the worst case volcanic eruption look like? What would the worst case landslide look like? And then we want to remember our secondary events. We want to pay attention to our tsunami. Now, you need to keep in mind these interactions between the volcanoes and the earthquakes and the landslides, because there could be cases where the combination of 2 events makes the event significantly worse, which you would 100% still want to risk assess, but start it simple. Just a side note with tsunamis as well, They're international events, so you might not be impacted by the earthquake or the landslide or the volcano, but still get impacted by a tsunami. So this was seen in the 2022 Tonga volcanic eruption, which generated a tsunami and resulted in an oil tanker at a refinery in Peru losing 6,000 barrels of oil as a result of a loss of containment. Now, there's approximately 10,000 kilometers between Peru and Tonga. So these events cover mass scale of areas. So the same principle can be applied to hydrological and meteorological events. So we've got a few more events here, but essentially a lightning strike can cause a wildfire. Wildfires, heavy rainfall, and tropical storms can increase erosion rates. We can have something called thunder snow in a winter storm. The storms, erosion, and heavy rainfall events can all cause flooding. And there's an interesting feedback loop between flooding and erosion where a flood event can speed up the erosion rates, which can then make the next flood event more severe. You've also got the potential for tornadoes with some of these storms. So again, we're getting to a position where this is going to be a very complicated and very complex risk assessment. So what we're going to do is we're going to simplify it. We're going to look at each event in isolation. We're going to look at the associated hazard. And then we're going to go back and check that we are happy that there is nothing that could make something else significantly worse if they were to coincide. So once we've identified what natural hazards we could have, we then want to do our baseline screening. So for this, you want to start with your list of natural hazards, and then you have 3 aspects that you're going to want to consider. First of all, if you have hazard screening maps, you want to use these as much as possible. Now, not every event will have a hazard screening map, but some events we're automatically going to always just screening anyway. So in the UK, I would always expect to see high temperature extremes, low temperature extremes, windstorms, and thunderstorms, because these are events that can impact the UK year on year. You do sometimes end up in a case where we don't have a hazard screening map and it's not always going to be appropriate to screen them. So here you have to make a qualitative assessment. So an example for that would be wildfires in the UK. So we don't have localized hazard maps to show where these could occur. So it takes looking at aerial imagery to look at, well, where is the nearest vegetation area? What is the risk to the site? How close is it to the site? Are we thinking thermal radiation impacts, or are we just thinking embers? So there's lots that goes into this screening section. But the idea is this all comes together to give you a list of credible natural hazards that could impact your site and, importantly, your surrounding area. Now, this doesn't mean that these are all going to cause NaTechs, but these are what you want to look at for the potential to cause a NaTech. So once we've done our baseline screening, we then want to come in and look at our climate change screening. So for this exact same list of natural hazards, you want to consider how climate change could influence each of them. Again, we want to be using hazard maps and climate change data where this is available. Now, we need to remember that climate modelling is evolving, so we need to be clear on any assumptions we're making, and we need to remember to review all this information at appropriate intervals. These assessments should never just sit on the shelf. You should be using them. So we're going to circle back to our secondary hazards. So once we have our list of natural hazards, our list of climate change events, we need to just confirm that we're happy there are no secondary events that could occur. Now, history has taught us that secondary events can be the trigger to a NaTech event. So if we use Fukushima Daiichi as a case study, so on the 11th of March 2011, there was a magnitude 9 earthquake off the coast of Japan. Now, the earthquake was detected at the plant and the nuclear reactors automatically shut down, and the diesel generators then turned on to pump coolant around the cores. So this was designed as a safety feature. Now, if you're looking at this in hindsight, you may decide, well, our safety features work, so everything's fine. However, a magnitude 9 earthquake is actually a very strong earthquake, and it triggered a tsunami. This tsunami is what overtopped the seawall and caused flooding to these diesel generators, which ultimately resulted in these failing and the nuclear meltdown taking place. So all of a sudden, our primary hazard was protected against, but it was our secondary hazard that caused the NaTech impact and the NaTech consequences. So it's just really important that we understand where we're at risk from these additional secondary hazards. So now we've looked at what could impact our site, we need to look at now how it does impact the site. So when we're looking at the severity assessment, essentially what we want to identify is where a NaTech could occur. Now, we need to remember that NaTech is a technological accident, so it doesn't necessarily have to be a major accident hazard. Obviously, where we have major accidents, we definitely want to make sure we know where this overlap occurs. And we also need to know where we could be compromising our safety barriers or our emergency response capabilities. So to do this, I use a qualitative risk assessment approach. So we use a series of questions to identify what could happen. There is ways to do quantified or semi-quantified assessment in some cases, although the methods are usually very complex and rely on the availability of data in the first place. So I prefer the qualitative assessment approach because it means I can compare multiple different natural hazards. As with any assessment, we also want to make sure that this severity is always unmitigated. So when we're looking at NaTech events, we want to look at what could physically impact our site and what could impact our site from an off-site perspective. So this is called direct and indirect impacts. So our direct impacts is anything that occurs within our site boundary. Our indirect impacts is anything which occurs outside of the site but has the potential to impact the site. So think about things that could affect your ability to run the site safely or respond to an emergency. Some of these aspects will fall both into direct and indirect impacts, such as utilities and human factors. So how do we do this? Essentially, first of all, we want to split the site up into nodes. We want to make this manageable. We then need to look at what our baseline assessment is. What is our risk today? We then need to think about, well, how does climate change impact this? And finally, we want to have some sort of severity ranking just so we can prioritize our risks at a later date. So if we start with the nodes, essentially at this point, you are doing a hazard study. So we want to split the site up in a way that makes sense. And this is going to be very dependent site on site, dependent on processes or the size of the site. So for a really simple site, such as an oil storage site, I think more, how would I split this up for hazard study 2? But then I'd step back and focus on the entire installation. So rather than looking at a single tank, I would look at the tank farm or that tank bond. For the more complex sites, we might decide to split this up by process unit or and then to further split that in between indoor and outdoor operations as necessary. The key is you need to be careful of where geographically things sit. So you want all your equipment to be located in the same area. The goal is essentially to make sure that the nodes are small enough to capture everything, but not so small that you're overly complicating this assessment. So once we have our nodes, I will then go for a wander around the site with a site operator or whoever is supplied by the site as someone that's seen the site in all the different weather extremes, and ideally you want someone that's been there for quite a while. So I'm not going to lie, these assessments may require a little bit of an imagination, and it's really important not to rule things out just because it's not happened at this exact site. So the first thing I do is I talk to the site. What is their current experience? Are they having issues already with pumps, with lines freezing? Is there anything that they're concerned about today? I then look at what can I see? Is that tree really close to the fence line? In a windstorm, could the tree collapse and fall onto my pipeline? This is also really good to a way of confirming any assumptions you've had to make with the screening process. So if I'm looking at wildfires, I'll pay attention to how tall is the tree? How close is the tree? Is there any bushes? There's lots of things you won't necessarily see on a site tour until you're actually looking for them. So those are aspects I discuss whilst I'm walking around the site. Offline, I will then look at what theory and past incidents tells me could happen. Now, past incidents are a really great way of showing what could happen. And it doesn't matter if it's a hurricane in the USA, I can still apply those lessons to an event in the UK. We will still have strong winds. We will still have flood risks. So it's a good way of learning what worked, what didn't work, what could we be doing, what would the outcome be of a loss of containment. So that all looks at our sort of direct hazards and our physical impact on the site, but we also want to consider things such as loss of utilities and access and human factors and emergency response. This is where the overlap between the direct and indirect hazards could occur. It's really important to remember that for indirect hazards, the natural hazard doesn't have to actually impact your site as well. So it could be that it's a flooding event, your site remains dry, but the transformer station that supplies your site with electricity is flooded. So all of a sudden you've lost your electricity supply. So there's a number of things we want to think about when we're looking at this kind of aspect. So when we're thinking about utilities, yes, we want to look at loss of electricity, communication, water. You may already have some of this in existing hazard studies, but you also want to think about what if you lost everything at once? These are wide-scale events, some of them. So there is potential that you lose water, electricity, gas, and communications all in a single natural hazard event. And there's interactions between utilities and human factors and emergency response and access. So if we're losing water, how is that impacting your emergency response? Is your equipment damaged in the first place? Can you even get to your site? Can the emergency responders get to your site? Can site personnel get to their site? Can you get around your site? You also need to think about who's attending externally from an emergency response perspective. So you may run all of your emergency response scenarios with your local fire rescue service, which is great. However, in a natural hazard, they may be unavailable. You may end up with someone from the county overcoming to respond to your major accident that's occurring at your site. Do they know what to do? Are they aware of your site hazards? These are all sort of things that we need to be thinking about when we're looking at these types of events. Aimee is a really good case study for looking at sort of how loss of electricity can escalate up into a NaTech event. If you are unfamiliar with this event, I highly recommend you watch the CSB video. So we've worked out our nodes, we've got our baseline risk assessment. So now we want to think about how does climate change impact this assessment? Now, what we want to look at is the difference between now and what we think is going to happen in the future. There could be cases where we don't think our NaTech risk is going to increase. There could be cases where our existing NaTech event could get significantly worse. And there may be cases where actually in the future we're at risk of a NaTech that we're not at risk from now. So if we use our picture as an example, in this case, the current risk, the floodwaters is quite low in the bund, isn't going to be impacting on the tank or the pipe work. So you could make the assumption that, okay, we're not going to float our storage tank or our pipe work. The worst case would be we've lost a little bit of containment within our secondary containment. However, with our future risk, all of a sudden this flood depth has increased significantly, and now we're at risk of floating the pipe work, breaking tank side connections. Depending on the diesel tank level, you could potentially also float that tank and have a loss of containment. So we need to understand how that is going to change over time and when we need to start thinking about measures to reduce the potential impacts of this. So once we've identified our current risks and our future risks, we need a way to sort of rank these and map them to our major accidents so we know what we're looking at going forward and to help with risk prioritization. So how do we do this? Now, there's potential that multiple major accidents could happen at the same time. And the way we rank these sorts of events is going to be very site dependent. This is especially the case if you're a coma site in the UK versus those under environmental permitting regulations. So this is just an example of how you could rank. So what I would do for coma sites, if it could trigger a major accident scenario, automatically it's the highest category. But things like process disruptions where we're tripping pumps and people are having to go and restart the process, I might rank that as minor because we're not having losses of containment, we're not having fire and explosions. A lot of the risk ranking will also come down to business decisions and risk appetites. So if we are using nodes and we are severity assessing and we're severity ranking, why do we need another hazard study? Why can't we just use our existing hazard studies? Well, you can, but the issue you have is with NaTechs is you have to step back and look at the site as a whole. You need to look at the bigger picture. This includes your indirect hazards. So it may be safer to just have a standalone assessment, but draw from your existing hazard studies. So an example could be that in a HAZOP, you've identified that a pump struggles at high ambient temperatures, and you've detailed how this all fails and all the measures you have in place. Take that and put that into your NaTech risk assessment. The other way in which we can use our existing hazard studies is when we're looking at projects and design, because actually, if you put natural hazards into your sort of existing guide words, this can help you design for the future. So it may be currently you've decided that you're going to have a design envelope of 35 degrees C for ambient temperatures because it's an ambient process, which is fine for current conditions. It's not going to cause you a problem. But then climate data showing in sort of 10, 20 years time, this temperature is going to be exceeded more frequently. So all of a sudden you could start having pump trips or equipment having issues. So you might decide actually at this design stage, we're just going to up that ambient temperature. We're just going to increase our range for our design envelope to help monitor that. So by putting natural hazards in at the design stage, you can then start to build resilience into the system, which may then help you and prevent needing to retrofit these aspects in the future. So we've looked at what could go wrong. We've looked at how this may impact us. So now we need to be thinking about what our barriers are and what more we can be doing. Now, there's not a golden list for this. When we're looking at barriers, we need to understand what we have in place, but we need to be careful because NaTechs can be a common cause event, resulting in all the failures of all the barriers that we have to prevent this one thing from happening. So when we're looking at barriers, it's obviously going to be very site specific and depending on what that site has, but we need to be careful that we're not placing over reliance on certain barriers as well. So flood defences can and do fail. I would never want to see a risk assessment that says nothing bad can happen because we have a flood defence. We need to remember that bunds are designed to keep liquid in, not out. So there is potential that the walls fail under the weight of the flood waters, or that the flood depth is higher than the height of the bund wall, so it's just going to overtop it. Depending on your source of flooding, you've also potentially got debris in the flood waters, which could cause damage to equipment or to the bund wall itself. If we're looking from sort of a fire deluge point of view, we need to think about whether or not that natural hazard could prevent the system from working. So could a lightning strike hit that part of the equipment, or could we have issues with lines freezing if it's a really cold day? So not only do we need to think about what barriers we have, but we also need to think about what more we can be doing. So this isn't a simple question. It's very complex, and part of that complexity comes because natural hazards are very complex. So one way I do this is I look at to see what other industries are doing for inspiration. So could we install a flood door? Is all the electrical equipment at height? Can we build a flood defence? We also need to consider what more can be done could be limited under the climate change impacts. So it could be that we've decided that, yes, we need to build this flood wall, but actually we don't need the flood wall yet. We might not need it for another 10, 20 years. So we're going to identify this. We're going to pull it in as a recommendation, but we're not going to action it for a number of years. So it's also important to understand that there's going to be a number of limitations to these events. You'll not be able to protect from every natural hazard and for every return period. The idea is to build resilience to these events and ensure that any measure we do install doesn't negatively impact the risk to people and or the environment from the day-to-day activities. So we want to control what we can and understand where we can't. By negatively impact the site's risk, when you're looking at, say, flood risks, for example, one of the measures you would have for surface water runoff would be to make the concrete floors permeable to reduce surface water runoff. Now, in a residential street, that shouldn't really be a problem. But on a coma site or a high hazard site, we don't want to introduce risks to the environment. So we want to keep that impermeable flooring. So we're protecting the soil and the sediment and the groundwater. So there is sometimes a trade-off between managing our NaTech risks and ensuring we're protecting people and the environment. The other aspect we also need to make sure that we're doing is following the recommendations through to the end. So there may be cases where we've identified something, think, great, we're going to action this, and then nothing happens to it. We need to make sure we're following all of these from start to finish, even your climate change recommendations, which is why we put in trigger points. So an example for this is the Lake Charles Biolab facility. So Hurricane Laura occurred in 2022. Now, with hurricanes, and it's the same with flooding and some of the other weather events, we get a bit more of a warning that they're going to happen. So you can prepare before the event sort of makes contact with the site. So the Lake Charles facility stored TCAA, which composes on contact with water. So because of this, the site decided to transfer all this TCAA product to another site. Now, for whatever reason, 2 vehicles failed to attend, which resulted in product being left behind. So the next day, the hurricane crew arrived and they continued to prepare the site for the incoming hurricane. Because the TCAA was left behind, they were placed on pallets. The site was then evacuated due to the increase in the risk from the storm that was approaching. Essentially, what then happened was as the hurricane made landfall, the strong winds actually took the roof off the building which housed the TCAA. So the TCAA is now exposed to the water from the rainfall, which unfortunately resulted in the decomposition of the material, which then ignited and there was a chlorine gas release, which then further damaged the building and caused a more severe structural damage. Now, the interesting thing with this case was there was a lot of lessons learned. One of them being that the lessons learned from the Arkema event were not applied. The process safety analysis, which had occurred 10 years prior, had actually identified a potential issue with this roof in strong winds, and they put a recommendation in to go and look at the roof. But for whatever reason, this was never actioned and it was never followed through. So this is why I say it's really important to follow through your recommendations, because if you've identified something that could be a problem, we want to close it out before it is actually a problem. The other aspect that was really interesting in this case was actually the hurricane crew that was assigned didn't know how to run the backup generator system, which was ultimately required for the fire protection system. So from this, we need to just make sure that anyone that's responding to a natural hazard, that multiple people, if not everyone, knows exactly the basics of what to do and how we are running our the relevant equipment. So we've looked at our screening, we've looked at how to assess it, we've determined what barriers we have and what more we could be doing. So now we want to think about emergency response planning. Now, again, this is going to be very dependent on site, so I can't give you a gold-plated, this is exactly what you want to do. But we do want to be thinking about, do we have procedures and for emergency response plans? We need to make sure that any plan has relevant information so that any fire rescue service can aid a site. You also need to think about the fact that you might need different plans for different hazards. A wildfire and a flood event are going to look very differently. And remembering that we could have more than one NaTech event at the same time, i.e. you could potentially float all of the bonds at one time. So what do we put in our emergency response plans? So if you can have a pre-plan, you might decide to put in your utility isolation points, so you know how to isolate your mains gas supplies, or information on what to do at the different stages of alert, and make sure that every time you have these alerts, you still actively go through each stage of this procedure. It may be that in the end the alert gets cancelled, but you don't want to take that risk of it not occurring. You can also include things such as hydrant and foam locations in your actual emergency response plan or any other firefighting information. Major accident hazard maps, any escalation events, are you at risk of boil over? You need to assume that the people who are turning up to your site aren't aware of your hazards in these cases. Flowcharts are also a great way to support decision making. So the thing with natural hazards is it depends on the hazard, but potentially the person that's supposed to make these decisions may be unavailable. So you'll want something to help whoever then has to make the decisions know what they're making. So if we use flowcharts, it will just help guide them on what we're expecting people to do. Again, this comes back into human factors. We also want to make sure we are testing and reviewing our plans. If you are a coma site in the UK, this will be expected. So we should be testing them, we should be reviewing them. If we have a case where it's a false alarm, use that as a test. Check, did everything work? Was there anything we could improve on? So once we've screened, we've assessed, we've worked out what more we could be doing and emergency response, we then need to look at our management system. Now, the next webinar on the 5th of March will actually cover management systems in detail, so I'm not going to go into them exactly. But essentially, we want to be making sure that we're reviewing the risk assessments periodically. We need to remember that climate change is a creeping change, so it's important to monitor, to review, to record data. We want to be using our baseline risk assessment as the starting point, and then we want to build upon that. If we have climate change recommendations, make sure we have trigger points so we know when we need to action those proposed changes. It's also very important that top management have an oversight. They need to understand the risks associated with these events and a lot of decisions which come down to business risk and risk appetite. So hopefully that's given you all an overview of one way of conducting NaTech and climate change risk assessments in the process industries. Like I say, these processes, involve a lot of thought and are very complex, but using a framework can help give you a starting point. As I outlined at the start, this is just one type of framework. Other frameworks may be available. The key is to build resilience to these events where we can and understand the limitations and boundaries of what we can achieve. Yes, they are hard, but would you rather not make informed decisions when determining how to best protect your site? I've also just added in a couple of references at the bottom of the slide, which provide really good information. The CDOIF guidelines also signpost a whole host of different guidelines, which can help you when you're looking at these events. Before we move on to the Q&A, I just have one final thought. Natural hazards by their nature are difficult and unpredictable, but how we as a society prepare, react and respond can make all the difference. Thank you.
Thank you very much, Aimee. That was a really excellent talk. You covered an awful lot of ground, and you presented a very logical process and procedure for taking us from the very start of considering what might impact our site right the way through to practically doing things about it and ensuring everybody's informed, etc. Excellent talk. We've got a bit of time now for Q&A. Those of you in the audience that have some questions for Aimee, please do post them either in the chat or the Q&A. And Aimee, or indeed Mike as well, will answer those questions as we go through the remainder of the webinar. Just to get us started, Aimee, I've got a first question for you. Which really is around the hazard maps. What is the range of coverage of these hazard maps in the UK, for example, in terms of the natural hazards we might encounter here and the the geography of the UK, the sort of spatial coverage of them? Could you sort of outline that a little bit?
Yeah. So UK is actually pretty good. So flood maps, we have flood maps. So the Environment Agency, Natural Resource Wales, CEPA, they've all got flood maps that give us lots of information about what could happen. Same with coastal erosion. So all of England and Wales's coastlines are mapped, and they have something called a shoreline management plan, and that shows you how it could erode. It then goes up to sort of the bigger survey has a data set called GeoIndex, and that provides things like subsidence risk both now and in the future, but this was starting to look at bigger scales. So you might not have your exact risk at a set point, but generally for your region what that risk could be. So it does vary. Yes, we could always improve. We could always have, more hazard map data available, but what we have got is very good. There's not that many events that we have to sort of use a qualitative assessment for.
And I guess, as events become more common in the UK, these hazard maps are extending. I mean, maybe 10 years ago, we didn't really pay much attention here in the UK to the possibility of wildfires. But of course, in the last 3 or 4 years, we've seen a dramatic increase in the awareness of the potential for wildfires and indeed the incidence of wildfires. And so I guess there then becomes a stronger focus on that particular hazard. So I guess over time, this database, if you like, for mapping is increasing. Is that what is the current situation in terms of development of these? Where is the focus today? Where are the hazards that we didn't used to consider that are now being recognised as something that we really need to consider beyond wildfires? Are there any others?
So Tim, I would say look to the Met Office and the UK climate projections web pages,
Yes.
because the Met Office coordinates a collaboration for the UK, which is a rolling programme of research into natural hazards and the climate impacts that will influence those hazards over the remainder of the century and beyond. And that is really tapped into the latest science on climate impacts, and the outputs from that, again, a rolling evolving program of spatially defined data, so you can now have mapping tools where you can pick an individual location in the UK, and the tool will provide you with current information, present day and future information. Now, if you're somewhere else in the world, of course, each different country has its own equivalents of Met Office, government bodies who provide the information. And as with process safety, the ability to foresight present day and future risks is what enables us to plan and become safer. So with managing natural hazards, getting the information, knowing that these threats are increasing, enables us to build in design and operation. But also, as Aimee mentioned, importantly, when you have just a few days warning with weather warnings, you can then react to make sure that when the event does occur, you become safe. And one of the UN's key drivers at the moment is to improve globally the availability of those severe weather warning systems, so that across the globe we can benefit from the sorts of things we already have in the UK.
Yeah, and that was really going to be my next question, Mike, was around what the availability of these hazard maps is internationally, in different countries, and I guess across the EU and potentially in countries like Canada and Australia and places, the coverage is extensive. But I guess once you go into you have process plant in sub-Saharan Africa or potentially India and across the Pacific region, I guess it's less well covered. Is that your understanding, Mike and Aimee?
Yeah, so
Right.
it is massively just going to depend on where you are in the world, what information is available to you. But that's also why I say look at what events could happen in your region, because even if you don't have a list of, yes, this is exactly going to happen at my site, if you know that you could potentially experience a cyclone or you could potentially experience an earthquake, you can start to assess these anyway. Always err on the side of caution when it comes to these sorts of events.
Indeed, as Aimee said, a qualitative appreciation of risks can help you hugely to plan. Don't dismiss just because of uncertainty.
Yeah, and I guess many of the companies that are operating in the plant in these countries are international companies, so they can draw upon their knowledge from an area that's well covered to undertake a qualitative assessment in the areas that are less well covered. Aimee, I was interested to hear you talk about postponing investment in potential barriers to a future date. so that everything doesn't have to be done at once, because we can wait to see how the science evolves and how the our understanding of how to respond to that science in terms of design approaches and physical construction processes on sites, etc. I guess this is really essentially what you're talking about, is an adaptation pathways approach. That's nicely summarized in BS 8631. Is that what you're thinking there? It's sort of putting in trigger points for investment at a future date, so we don't become overwhelmed as a plant operator or manager with the amount of change we have to make to the plant on day one.
Yeah, that's exactly the viewpoint of that. So it could be that you're looking at your flood risk now and you're not at risk of flooding. Like, I do have sites that I look at and their flood risk now, their flood risk maps aren't showing a risk. But when you're looking at the flood risk maps in the future, they are showing a risk. So you don't want to put loads of investment in now for something you're then going to have to maintain, which potentially could then be degraded by the point you actually then need it. So you're just going to have to re-spend all that money. So yes, we want to make sure we've got barriers for things that can affect us now, but we don't need to put the barriers in for things that could only affect us in the future.
Yeah, and I think Mike has just posted in the chat the link to BS 8631, and I think that for everybody on the call, this is worth having a look at wherever you work in the world, wherever you're joining us from, because the methodology in there and the approach is relevant everywhere. I'm just looking through the Q&A in the chat, and I've just seen something here has come up about climate change has become a political issue in the USA. And we're all aware of that. I think all of us that operate in this area are familiar with the challenges associated with that. So it says that it's important to avoid mentioning climate change when discussing adaptation in those locations, instead stressing that climate has and is changing, whatever the cause. The big insurance companies have to pay the bills for NaTech damage and do a good job on that. And many of those are headquartered in the USA. I mean, have you noticed, Aimee, any change in the last year or so in terms of the willingness for plant operators and owners to consider climate change risks in regard to NaTech?
So it's definitely something that in the last sort of 18 months, 2 years has very much come to the forefront in my workload. And even as a company, we're having lots more of these conversations of, well, have you looked at your NaTech risks? Or people are coming to us to ask us to look at their NaTech risks. But I think part of that is also from a regulator standpoint, there is sort of more awareness and questions are being asked of, are you being prepared? So it's sort of, it is coming to the forefront, but I think part of that's lots of different sort of areas at play. Part of it will be insurance companies, part of it will be regulator expectations, part of it will be, it's a business risk at the end of the day. If you, have a major accident at a site, that's a massive business impact. If you could do something to prevent that, why wouldn't you? So it's sort of all very quickly coming together, I think, in industry.
Yeah, and I think it's really important that that organisations recognise that different departments will be grappling with the same issues. So whilst Aimee is focused on safety and environmental protection as a driver, there is a massive amount of work going on in finance, all under the banner of the Task Force of Climate Financial Disclosure, where, as Richard noted in the chat, the big insurance companies are on this. Governments are on this because governments often underwrite risk. And now there are legal requirements to disclose the risks associated with climate change, so that investors can and are making decisions on how they finance industrial projects. So yes, if you're in process safety or environmental protection and you're grappling with how to risk assess, talk to your finance department because they might be doing the same.
Yes, yeah. And I suppose this comes to my next point, really, Mike, which was around collaboration, um, and being aware of other parts of it internally within your company and externally in your local environs around the plant that are themselves undertaking climate risk assessments and looking at the impact of hazards and how to respond. And I guess that was going to be my question to Aimee. I didn't really hear a lot about collaborating, in terms of those indirect impacts, collaborating with those organizations locally that potentially will be those that are impacted by these directly by these indirect impacts and therefore impact you, and how much scope is there within your work for taking the conversation, the collaboration outside the boundaries of the plant to ensure that there's a more sort of integrated approach in the local environs and within, say, 2 or 3 miles of the plant to ensure that the whole system it understands what other parts of the system are doing.
I mean, collaboration is definitely like a good way of assessing just natural hazards in general, because, if it's not just necessarily you that's going to flood, if you're looking at flooding. So it could be that actually you could have the electricity companies and the sites and all these other people band together to put the defences in place and fund these defences.
Mm-hmm.
So yes, in answer to your question, collaboration is very important. It's just finding a way to create that platform to allow for the collaboration to occur. And that's maybe something where the regulator gets involved as well, because at the end of the day, managing these types of events is a combined effort. It's not on a solely on a site, it's on everyone.
Yeah,
indeed. There's lots of areas where we do collaborate. So at national level, I suppose, like consultancies, you see a lot of different techniques, a lot of different practices. Regulators can disseminate those good and best practices. At a local level, we are in the UK, the Environment Agency, a regulator and a Category 1 responder. So we already have integral links into the local resilience fora, which manage the collaborations between responders. And of course, if the site is a high hazard site under the COMA regulations, the Seveso directive, there are duties within the regulations to collaborate across emergency responders to plan for scenarios. So what we'll be looking for is that the NaTech events, the climate impacts, are feeding into those risk scenarios, and that the emergency planners across all responders are thinking the thoughts that you've explained today in terms of how the different interactions between these cascading risks could affect those emergency plans. So there are lots of different collaborations that NaTech management can benefit from on different levels.
Okay. Thank you, Mike. And just finally, I'm conscious of time, and we have a minute to go. So, but we do have a technical question here that I want to just address before we drop off, and we may keep the webinar going for another few minutes. Often, extreme weather events are rated as 1 in 100 or 1 in 500 years. For example, Aimee, how do you consider those? For instance, if a project has a 60-year design life, that 1 in 500 event may happen during the life of the project and then not happen again for another 450 years. Do you design for it or consider the likelihood of that? I mean, how do you address that issue?
So when we're talking about a 1 in 10 year or 1 in 100 year event, we're talking about the probability of that event occurring. So year on year, it's the same probability. So that's one of the key differences with natural hazards, is we're always thinking about probability. Now, whether or not you design for, I mean, I would always recommend you at least design for a 1 in 10, if not better. Whether you just decide that you're going to design for that 1 in 500 year event, it's going to depend on what it is you're designing. But also, this is where it comes back to being more of a business risk and a business decision. So there's not necessarily going to be a standard that tells you you have to design for this. There might be some standards out there that tell you what you need to design on. But unfortunately, this is one of those where it's down to you as a company or an organization to decide that this is what you're going to design for, and this is how we're going to make sure that we limit those impacts. It essentially comes back to the fact that you're never going to be able to design for every natural hazard. So, and we have to accept that there's going to be things that we can't design out. So sometimes it could be if you're looking at a 1 in 500 year flood event, that's such a big event that you physically, with all the will in the world, cannot design that out in your plant. So sometimes it's going to be more about what you can do rather than what you want to design to.
I think there are analogies here with designing around airports, because airports have risk contours, which if you're building an airport tank farm, you will want to think about where the more probable areas of aircraft crash could be, and you site out of the risk contours. Now, in the same way, an airport can evolve and expand, and those risk contours can change. The natural hazard risks can also change and evolve, increase or decrease over time. So you can pull in that analogous thinking to do the risk mapping in semi-quantitative or quantitative ways.
Okay, look, thanks, Mike, and thanks, Aimee. I'm conscious of time, and we're starting to. People are starting to leave, which is quite rightly so. I want my lunch too. Okay, well, look, thanks very much. I'm going to hand back to Richard now, who's going to close the webinar as the IMechE host. Thanks very much.
Thanks. I mean, really enjoyed that. We could do with another hour of this, but there you go. You can't have everything. For those who are not aware, the Process Industries division of IMechE has a lot of stuff that we upload to YouTube, the webinars in particular. Currently, we've got 107, but if you went on the general IMechE in other divisions, you'll find many other videos as well. So there's a link there, but you just look it up on YouTube, IMechE, you'll find it. We have got a couple coming up. This one I think would be really interesting, about PFAS. So that's in 3 and a bit weeks time. This is an update on what's going on around PFAS. So I think all engineers and scientists should get involved in and look at that. Again, if you look, you'll find it if you look on that other link. And we've also got some case studies coming up on some reliability-based ones. This is a transformation of asset integrity management at an oil refinery. It could be somewhere else, but it's just shares some good examples of what's possible now. And technology has changed, techniques have changed. There's a lot going on that maybe you're not aware of, but actually you might be able to use, whether or not you're in a refinery. So look on YouTube. Search for these things. Certainly, if you're on LinkedIn, please join our division because you'll get early notice of these. If you want to feedback on this, there's a QR code there and some links down there. If you don't manage to capture it during this webinar, they'll be shared in the recording anyway. So on that point, I think we're done. Again, I just found it fascinating, Aimee, and the input by Mike and Tim. So I look forward to the next one, the 5th of March. The details aren't there yet from iChemie or IMechE, but they will be fairly soon. So please join us through LinkedIn, because that's where you tend to find out things pretty quickly. And at that point, I'm going to end the event and say thanks again.